Greetings from GNU Linux Users Group. I, Sudhi, on behalf of GLUG, welcome you to our event CTF Bootcamp. Now, what is CTF Bootcamp? It is an event which is tailor-made to introduce beginners to the world of cybersecurity and capture the flag events. So, the word CTF may seem to be quite intriguing to you all as beginners. So, at first, let's understand what is CTF. So, a CTF or capture the flag is a cybersecurity competition where participants compete to find hidden flags or pieces of information in computer networks or systems. These flags can be hidden in a variety of ways, such as in the source code, in certain web applications, or even in physical devices. So, in CTFs, we are basically have to find out flag. As the name suggests, it stands out for capture the flag. So here we have to find out a flag. The flag basically goes like the CTF name followed by the flag content. Now let's try to understand why should we even play CTFs. So CTFs are a great way to learn about cybersecurity and test our skills in a fun and challenging environment. So they can be played individually or in a team and can help us to learn a great deal about cybersecurity. So on the other hand, top performers in CTF often receive various recognitions and prizes which serve as incentives for them. Moreover, playing CTFs is recognized by various recruiters and can serve as achievements as valuable skills and a candidate's aptitude. So CTF has a lot of categories which include binary exploitation, reverse engineering, web exploitation, cryptography, and forensics. So now let's delve into each of the category one by one.
One of the most popular categories in the Capture the Flag contest is binary exploitation. So let us see its formal introduction. Binary exploitation in Capture the Flag contest is referred to as PWM. It involves finding and exploiting vulnerabilities in binary executable files. Some of the most common exploits are buffer overflow, integer overflow, shellcode injection, format strings, and return-oriented programming. Pawning in CTF contests are like solving a puzzle where you play both the detective and the villain to find the vulnerabilities and actually use them. To get started with PWM, some basic knowledge about C language, computer architecture, and assembly is preferable. So now let us solve a question based on binary exploitation.
So let's solve a question on PicoCTF. As you can see, it has a tag of binary exploitation and it has 15,000 solves. So let us move on to the description of the question. The description says it is a simple buffer overflow and we even have the executable file of the program here and we even have the source code here. And we can even connect it using the netcat line. So let us try the netcat function first. When I netcat to the network, it asks me an input. So let me type an input and you can see the program has been exited. So let us move on to the source code. When we go to the source code of the question and I'll copy this link, I'll use wget to get the source code file, and when I download the file has been downloaded. Let us see the source code. Here in the source code in the main function, you can see that there is a file called as flag.txt which we are reading, and there is a signal handler here which handles the signal of segmentation fault, and this is our input that is taking our input. And here, so what are these two functions at the top? We can see that the segmentation fault is printing our flag. So we need to make a segmentation fault, that is by overflowing the input, and we'll get our flag output. So we'll again netcat into the code, and as you can see, it asks for an input. Let's just spam with ace, and once we make the segmentation fault, you can see that we have our PicoCTF flag. Let me just copy this and paste it here. You can see that we have solved the question.
Now we have a very interesting category, reverse engineering. Here you have to find the backdoors of a program to actually get your desired output. But why is this category called as reverse engineering? Why? Because you'll get the bytecode of the program for which you have to find the vulnerabilities for. You have to decompile this bytecode using some tools such as Ghidra, and then you will be able to find the vulnerabilities in the human readable format after decompiling the bytecode. Before solving a problem, let us see the formal introduction of the reverse engineering category. Reverse engineering in a CTF is typically the process of taking a compiled or a machine code or a bytecode program and converting it into a human readable format to understand its inner workings, functionality, and possibly uncover any vulnerabilities it may contain. Some of the common tools used in the reverse engineering category are disassemblers, decompilers, debuggers, static and dynamic analysis, code tracing, and memory forensics. You would say this is very easy, right? You'll directly decompile the code and you'll find the vulnerabilities in it. But here's the catch. As you can see in the flowchart, every time a source code is compiled, we lose information. And when you decompile this bytecode, we would have already lost a lot amount of information, and some of the integers and values that you need to actually use the vulnerability that you can find in the human readable code will be converted into a hexadecimal format. So again, you have to decrypt this hexadecimal values to actually use your vulnerability. So let us go on to solving the question.
So let's solve a question on PicoCTF. As you can see, it has a tag of reverse engineering and it has 9,000 solves. So it's a pretty easy question. So let us see the description of the question. The description says we can try reversing this file, and there is some sort of password for this file and we can find it. So let's see what's the file about. When I copy this link and when I use wget to download the file, and as you can see, we have downloaded the file, and let us see the permissions on the file. The permissions are read and write. So let us try executing this file by giving it executable permissions. When I give it an executable permission using chmod, and when I execute my write file, it asks for a password. So let's enter something random, and when you click on enter, it says access is denied. So to find the password, we have to get into the code. So let us try reversing the file using an online decompiler called as dogbolt. As you can see, we can decompile files here, and when I select my red file, and I'm using Ghidra to decompile my file, and as you can see, we have the decompiled code here. As I said, information is lost on every conversion, and when we convert them back, we have a little amount of data, and as you can see here, it's asking for our password. Here this scanf is taking our input, and they're checking after doing an strcmp operation. And as you can see, we got our flag itself here when we enter the correct password, so we can use this flag. So I'll just copy it from here, and we'll paste it here. Okay, and when I submit it, you can see we have solved the question again.
So now we are going to move towards the web category of capture the flag, which is also known as web exploitation. Now, what is web exploitation? So as the name suggests, web exploitation deals with the ways of finding out the various vulnerabilities, security risks and threats that are available in a particular website. Now, why is that needed at the first place? So, finding out these various vulnerabilities and potential threats can help us mitigating those errors so that we can enhance the overall security of a particular website. Now, as we know what is the importance of exploitation, let's understand how can we employ this. So, to employ web exploitation, we tend to use various tools like Burp Suite and an open source alternative for that, also known as ZAP. Moreover, we do various penetration testing, fuzzing tools, static and dynamic analysis, code review, so that we can understand the database and try to find out the various vulnerabilities that are associated with it. So today, in order to have a hands-on experience on how to solve problems in various CTF events based on this category, I have handpicked 2 problems from PicoCTF so that you can get a good enough overview of this domain and get started solving problems based on web category in various CTF events. So without a further ado, let's get started with the problem solving. So now we are going to solve the first problem from the web CTF category. So as I had said, the first problem will be based on robots. So the question says, where are the robots? So the question was from PicoCTF 2019 and it is indeed in the category of web exploitation. So the question description says, can you find the robots? So maybe this means that it may refer to something known as the robots.txt. But before that, we are provided with this link which we can visit to, and we are also provided with a hint. What is it? It says that what part of the website could tell you where the creator doesn't want you to look. So this may help us in finding out the solution to this particular problem. So let's visit the link. So on visiting the link, we are able to see a black screen where it is saying, where are the robots? So if you don't know, every particular website has a robots.txt. Now what is the purpose of this robots.txt? This robots.txt tells the various search engine crawlers or the web crawlers that what specific URLs and parts of the website it can access. So for that, let's visit to the robots.txt index of this particular website. So on visiting, we are redirected to this robots.txt. So on the first line it says user agent star. Now what does this mean? This means that every particular web crawler that is indeed present is provided with each and every kind of access. Now on the second line it says that disallow. So this is indeed quite intriguing because in the hint we saw that the website, from what part of the website we can tell that the creator does not want us to look. Now in case of the disallow, we can see that it is in fact not wanting us to visit this particular HTML. So let's copy this HTML and visit to this index. So on visiting, in fact, we're able to find out the flag. So I'm just going to copy it, and once I have copied it, I'm going to paste it in here. So after clicking on submitting the flag, I have in fact earned 100 points. So in this way, I have solved one of the problems. Now let's move towards the second problem. So the second problem, as I said, is based on cookies. So the problem name is in fact cookies. Now before delving into the problem statement, let's understand what are cookies. Now cookies are basically small pieces of data that are stored in a website. Now what is their usage? They are used to store user info, their preferences, and they can also be used to track user activity. So you can think it as a sticky note for a website in order to remember specific details about any user. So now let's read the description of the problem, where it says, who doesn't love cookies? Try to figure out the best one. So it basically points out to find out a specific cookie. So now let's navigate towards the link. Moreover, there are no hints to this problem, so let's go to the link. So here I am going to be redirected towards the home page, and inside the home page I am able to see that here it is suggesting a particular cookie name. So let's provide this cookie name and let's see what happens. So when I provided this cookie name, what is happening, if I click on this search button, then it is saying that this is a very special cookie. This is a cookie which is not that much special, and then it is printing a particular text. So let's see that what is happening with the cookies that are stored in this particular browser. So I'm going to go into application, and inside cookies I'm able to see that there is a name with the name and the value is 0. So now let's try to provide certain other information in here. So what I'm going to do is that let's again go to home. So now let's provide something which is not a cookie. Let's provide test. So if I provide in here thing like this, what is happening, that it is not going anywhere. On the other hand, what is happening, that it is saying that it is not at all a cookie. So let's again inspect, and if I go to application, we are able to see that the value of this cookie is set to -1. So this means that maybe as and when I'm entering the cookie, it is checking for what I'm entering and providing me values based on that. So let's try with something which is indeed a cookie. Let's let it be, say, gingerbread. Let's see what happens. So if I provide gingerbread as the input in here, and if I tap on search, what happened is that I was again redirected to /check, and what is happening, that I'm able to see that a particular response was generated, and it was I love ginger cookies. So again the same prompt that as I had got in the first response is being shown, that it is not, this is a cookie but not a very special one. So let's again inspect and see what is the value that is stored for this. So you can see that here the value is 23. So maybe that what is happening, that as and when I'm entering a particular cookie, it is making a post request. So for that, let's go to network tab and let's again go to home. So what I would do right now is that once I'm redirected to home, so let's see here. So now let's again provide snickerdoodle. So once I provide snickerdoodle, let's enter search. So we can see that a particular sort of post request is being sent to the URL check. So this means that whenever I'm entering something, it is basically searching for that particular cookie in the database, and it is basically generating a cookie value based on that particular cookie that I've entered, and then I'm navigated to the check route. So this is the overlying mechanism. So let's try to write a Python script that would basically generate random numbers from -1 to say 25, and I would try to find out the text PicoCTF, because the flag that is what we are supposed to find should indeed be containing the term PicoCTF inside it. So for that particular reason, what I'll be doing is this: I will be writing a Python script. So let's go to the terminal. So inside the terminal, I'll be going towards my desktop, and I'll be navigating towards a particular folder. So since I am going to make use of the requests module in Python to make HTTP requests, I'd be required to create an env. So how to create an env? So for that, I would basically do python 3 -m venv and env name. Now my env is going to get created, Now since it is created, let's activate this env by using source env/bin/activate. Now as I enter this, my env is activated. Now I'd be heading over to Sublime Text. So for that I'll be writing Sublime dot. But before that I need to install a package, that is requests. So for that I'll be typing pip install requests. So as I said, this would be used for making HTTP requests. So that has been installed. Now after that I'll be making a particular file and let us name it test.py. So for that I'll be using the touch command and I'll be doing test.py. So this is the file name. Now let's move to Sublime Text. So now I'm in my Sublime Text and in here what I'm going to do is that I'm going to write a particular Python code. So let's continue with the writing. At first I'm providing the type of compiler. This is just for the common purpose, no needs for that indeed. So at first let me select the file. So inside that I'll be providing the type of compiler that I'm using in here. Here I'm using Python 3, so that is why I'm providing the compiler name. So Python 3. Now what I'm going to do is that I'm going to import a particular module by using the import, then followed by requests. So importing requests. Then I'm going to press enter. Then after that I'm going to run a for loop. Now as I saw that the values of the cookie was generated in the range from -1 to 23. So let's run a loop from the range 25. Now let's set a cookie name. So for that I'll basically be setting the value based on the loop variable. So for that I'm providing the name, and by using the dot format I'll be basically changing it based on the loop variable. Now I'm providing the headers for this particular cookie. So the headers would be a type of dictionary where I'll be providing the cookie as a name, followed by the cookie that would be generated based on the loop variable. Now I'll be basically making use of the requests module. So for that I'll be using requests.get, and then I'll be making a request to this particular URL. So for that I'll be heading over to this, and then I'll basically be copying this particular URL, then I'll basically paste this in here, and I'll be passing in the headers as headers equals the headers that I have created. I'm in fact referring to this headers. Now once this is done, as I stated, this would basically do a get request to this particular URL, and that will be done for 25 times. Now what I'll be saying, if the status code means the response is status code is r.status code equals 200, that means that the request was okay, and moreover if the tag PicoCTF was present in this response dot text, then I'll be printing it. Now let's save it. So now, sorry, there was an error in here, so just let me give some tab. Now I'm saving this. Now let's go to the terminal. So now I'd be moving towards that directory where the file was present, and I'll be doing python 3 test.py. So the requests are getting made, and we have to wait for a bit until all the requests are made. So here we got the particular response in which the flag was present, and if we search a bit, you can see that here is the flag PicoCTF and then followed by the flag. So if I just try to copy it in here and now if I move in here and paste it, click on submit, and we see that we have successfully solved this problem. So this was all about solving problems based on the web category of the CTF. I hope that you would enjoy solving further problems on the web category in various other CTF events.
You have learned about the domain of web exploitation. It's time that you learn about a new domain, which is cryptography. Cryptography is a very important domain in the field of cybersecurity and also CTFs. As you can see on the screen, cryptography is the process of hiding or coding information so that only the person a message was intended for can read it. So for example, let's say I want to send a message to a friend of mine, and I encode the message with let's say an algorithm or another method which is only known by my friend and no one else. So then even if the message is leaked, the message will only be decoded by my friend because he knows the process of decoding, whereas anyone else who might have access to the message won't be able to decode it because he doesn't know how it has been encoded. The art of cryptography has been used to encode messages for thousands of years and continues to be used in banks, cards, computer passwords, and e-commerce. Modern cryptography techniques include algorithms and ciphers. For example, the Vigenère cipher or the Caesar cipher. And if you want to know about algorithms, then there are several algorithms. One of the most famous algorithms is the RSA algorithm, which stands for Rivet-Shabir-Edelman algorithm. The RSA algorithm harnesses the concept of prime factorization of very large numbers to find public keys and private keys, which are used to encode and decode information respectively. And these algorithms and ciphers enable us to encrypt and decrypt data. Now, as you can see from the flowchart, we originally start with a plain text message, which is in human readable format, and it is non-encrypted. Then we apply an encryption code or algorithm to the plain text, which encrypts it, and from the encryption process we get a cipher text. This cipher text is in non-readable format, that is, it is encrypted, and it can be decrypted by a person who knows how it is to be decrypted. If the person knows the decryption algorithm, then he can apply the decryption algorithm on the cipher text, and we get the plain text, which is again in human readable format. This was all about cryptography. Now we will solve some problems from PicoCTF on the domain of cryptography. Now that we looked into the domain of cryptography, we shall solve two problems in this domain on the PicoCTF platform. The first problem being the numbers, which is a simple cipher based problem, and the second problem is mind your P's and Q's, which is an RSA algorithm based problem. So let's start with the numbers. So you can see that numbers here is a file, so we download this file, and if you open the file we see that it is an image, right? Now if you notice carefully, then you'll see that there are two curly braces, And as you might know that in PicoCTF, every flag is wrapped into curly braces. So from here we get a head start. Now if we notice very carefully, then we can see that assuming A starts at 1 and Z ends at 26, 16th alphabet would correspond to P. Similarly 9 would correspond to I, 3 to C, 15 to O, and so on. So based on this pattern, we can see that this first few numbers represent PicoCTF. So that means the pattern in our cipher is that every number corresponds to the alphabet. So similarly, if we keep deciphering like this, then we'll see that 20 corresponds to T, 8 corresponds to H, and so on. We can write a Python script or a script in any other programming language to decode this flag, but you can also do it manually. So let's try doing it manually. So first few letters are PicoCTF, then the curly braces. This is the general format. And now we see 20. 20 is T. So we write T. Then 8 is H. And 5 is E. Then 14. 14 happens to be N. Then it's 21. 21 happens to be U. Then there is 13. 13 is M. And there is 2. 2 is B. And 5, which is E. Then 18, which is R. And 19, which is S. And 13 is M. 1 is A. 19 is S. 15 is O. And 14 is N. So we try and submit the flag, and we see that it's correct, and we earned 50 points. Now we'll look at problem number 2 of cryptography, which is based on the RSA algorithm. This is question number 2. So as you can see, there's a values link here. From this link we download the values text file, and you can see we have gotten some values. Let's just copy these values. Let's go to the terminal, and as you can see, we are already in the crypto directory, where we'll make a Python file. Let's call it rsa.py. We have created rsa.py file. Now we'll use a text editor called Sublime to write code into this file. As you can see, we are in the crypto directory, and this is an RSA file. In this RSA file, we paste our values that we got from the downloaded file. And now we'll talk a bit about cryptography. The RSA algorithm. So in RSA algorithm, the first step that we do is choose two random prime numbers. Let's say P and Q. Using these two prime numbers, we multiply them and find N. So N equals P times Q. Once we have N, which by the way will be used for encryption and decryption processes, we now find a function phi, which is known as the totient function, which is equal to P minus 1 times Q minus 1. Once we have phi, which is also called the totient function, what we do is find the public key and the private key. Public key is called E equals public key, and D is called the private key. Now the concept involved in finding public key is that E should be less than the totient, that is phi, and it should be greater than 1. So 1 less than E less than phi. and also E and phi should be co-prime, that is the largest factor common to both E and phi, that is their HCF or GCD, should be 1. Once we have E, let's say our message in the form of a byte string is M, right? So in order to encrypt M, we use the formula M to the power of E mod N. This gives us C, which is called the ciphertext. So what we are doing is we are raising M, or the original plain text message, to the power of E, and then we find its mod with N, and the result is our ciphertext that we already have here, C. Now once you have C, you can decrypt it using the private key, which is D, and the decryption process is similar. You raise C to the power of the private key, that is D, and you find its mod with respect to N, and this equals back to M, which is your original plaintext message. Now you might think that E is easy to find, but how do we find D? Well, there is a mathematical relationship between D and E, which goes as D E is equal to 1 mod phi. This relationship is used. So once we have E, that is the the public key, and phi, that is the totient function, we can use these two to find the private key, and once we have the private key, we can use this equation to find our original message from the ciphertext. So this was just the explanation. Now we'll do the actual process. So we need the certain libraries from the crypto modules. So we import them from crypto.utils.number import inverse comma long 2 bytes. These two functions will be useful in our decryption process. Now let's just make this equal to, because of Python syntax. Now we have C, N and E. So our function first off would be to find P and Q, the original prime numbers, which when multiplied give us N. Now N is a very large number, as you can see. It's a 42-digit number, and obviously you can't factorize it easily. You can't run a loop because it will run forever. So what we use is a database available to us called FactorDB. You can go to your browser and open up factordb.com. It opens up a page. Yes, and here you can type in numbers, and when you factorize you'll get the prime factors. So I already have my number here, so I factorize it, and see, I get the 2 prime factors involved in the multiplication process. So I copy these numbers, let's say this is P, and Q equals to the other number. So now we have P and Q. Since we have P and Q, we can find the totient, that is phi, which is equal to P minus 1 times Q minus 1. And now we have the totient. Now if you remembered the process that I told, once you have phi, you have the equation DE equals 1 mod phi, right? So using this equation, we know that D equals to E inverse, which is e to the power minus 1 mod of phi, right? So we'll use this equation, and this is where the inverse function comes in. So we can write D equals to inverse of E and then mod with respect to phi. This gives us our private key D, which will be used in the decryption process. Now that we have D, we can find the original message, that is M, and M equals to C to the power of D mod n, right? But in Python we'll write it in this way: m equals power, is the power function, c comma d comma n. The third variable is the mod variable, and that's it. We get our m, which is our decrypted message. But if we print m, we'll get a byte string that will be a large integer number. But what we want is the string message, so we use the long to bytes function here. So we print long to bytes m, and this should give us our required answer. So we close the editor, we go back to our terminal. Now we'll run the code, python 3 rsa.py, and you see that we have got the flag. We copy the flag, we go to PicoCTF, paste the flag, and we submit the flag, and it accepts the answer. So this was the RSA question. I'll just show you one more thing. In this code, if we didn't use the long to byte functions, then we would get a byte string of integers, as I'll show you. See, we get a byte string of integers, but to convert this integer sequence to our PicoCTF string flag, we use the bytes to long function, long to bytes function, and thereby we get our flag. So that was it for cryptography. Thank you.
Now let's move on to the next topic, and as next topic we have digital forensics. Digital forensics is integral to both cybersecurity and capture the flag challenges. It involves investigating electronic evidence to detect and respond to cyber threats. In CTFs, participants engage in forensic challenges that demand skills in file carving, steganography, and memory forensics. These all are the basic key techniques that are used in digital forensics. Digital forensics is also used in scrutinizing digital devices and networks using advanced techniques such as disk imaging, memory analysis, and network packet inspection. We'll get into all these techniques one by one. So to start with, we have disk imaging. Disk imaging is a kind of taking a screenshot, a snapshot of a crime scene. It involves creating an exact copy of a digital device, preserving its state at an instantaneous point of time, so that it will allow the investigators to explore the copied data without even altering the original state of that particular system, and it will also ensure a thorough investigation process. After that, we have network packet inspection. So to understand network packet inspection, let's first imagine that it is kind of looking at the footprints that is left behind at a crime scene. Network packet inspection is basically network packet inspection basically involves analyzing the data packets that is kind of moving across the network, and by scrutinizing these data packets, investigators and examiners can recognize and reconstruct the events, identify the event patterns, and then after that the origin of the actual threat or actual event that lead the threat to happen can be traced up by this network packet inspection. After that, we have another technique that is known as indicators of compromise, that is IOCs. So let's talk about IOCs. Like these are the clues that suggest a security incident that has been occurred, and it could be anything from unusual network traffic to or some suspicious file that came into your system. So it's kind of finding it's obviously the same, and it's kind of finding the fingerprints that is inside a crime scene. IOCs help in pinpointing the actual event that comes under digital forensics. And after that, another key technique we'll discuss, that is steganography. So what is steganography? It's kind of another intriguing method that is included in the digital forensics category. It's kind of finding a secret message within a painting, and in CTF challenges, participants decode hidden information within seeking the images, and that can be anything such as innocent files or images. It's kind of similar to disk imaging. This steganography method is used to basically showcase the actual threat from analyzing any painting or any image, and after that converting that information to a particular data set. So that's it. In the context of CTFs, participants obviously engage in forensic challenges that demand skills in file carving, steganography, and memory forensics. So that's all about digital forensics, and we'll now pick two problems we'll pick two problems from PicoCTF, and which comes under the digital forensics category. And the first problem will be based on nested file tracing, and the second one will be based on Wireshark network analyzer tool. We'll solve that problem using the network analyzer tool, popular network analyzer tool, Wireshark. So that's a little overview about digital forensics. Now we'll pick two problems from PicoCTF, which comes under the digital forensics category. And the first problem will be based on nested file tracing, and the second problem we'll solve using the popular network analyzer tool, that is Wireshark. CTF website, and we'll find some problems under forensics category. And this is the Matryoshka doll challenge. Fine. Now let's check the description of the challenge. It is a PicoCTF 2021 challenge, and it comes under forensics category. So the description suggests that Matryoshka dolls are a set of wooden dolls of decreasing size, placed one inside another, and what's the final one? And there is a link given for this image. Okay, so let's first get the image and try solving this problem. We'll get into terminal first, and we have created our directory where we will do all the tasks related to this problem. So basically we have created a forensics directory here, and let's first download this image. It is being downloaded. Cool, it's downloaded now. So first check the files. There's a one single image, that is dolls.jpg. Let's first check the image. It is basically a simple image of a Matryoshka doll, and there's nothing as such in this. It looks like a simple image. Now let's examine the image file carefully. We can do the examination of this kind of image file by tools like exif tool or binwork. We can use those tools to gather information about the file's contents, right? So let's use binwork and check the content in the image file. So we'll use for that you need to first have binwork installed in your system. So you can just install binwork by using sudo apt install binwork. Now let's use binwork and we'll check. See, it returns a set of datas, and basically it is it is returning the data that is within the image, that is embedded within the image. We can find that it is basically a PNG image of the certain resolution, and it's a 8-bit color RGBA image, and it is non-interlaced. Okay, and the next entry suggests that it includes a TIFF image data. After that, see that there is in the third entry we can see that it is a zip archive data. There is a zip archive data included within the image, and whose compressed size is given here. And as we go by the name of the question, that is Matryoshka doll, and it suggests a nested nested set of dolls that is placed one inside another. So this zip might help us finding the actual flag or reaching to the final endpoint of our flag. So let's first let's first extract this zip archive data. So for that we'll use binwork again, binwork -e, that will actually extract the dolls.jpg file, that will actually extract this archive data. So let's extract this, and it's extracted. Now let's list all the files. You see we have dolls.jpg, and along with that we have a dolls.jpg.extracted file. So as it is suggesting that there might be a possibility of nested files one inside another. So again, let's check what is exactly the dolls.jpg.extracted. So binwork dolls.jpg.extracted. It is showing another. So let's get into that directory. We are into that particular directory, dolls.jpg.extracted. Now list all those files inside that. See, there is a 42860.zip folder, and there is a folder naming base images. So let's see what is inside base images. There is another image, 2c.jpg. So again, I guess we'll run binwork to gather information that is within that particular image. Again, returned a set of data, that is, it is basically another PNG image with a certain resolution, and all these things, among all these things, what is actually important for us is this third entry that suggests that it is another zip archive data, and we should again do the extraction of this archive data. So let's extract this archive again. It is extracted. Now list all those files. See, there is another folder we have, that is 2c.jpg.extracted. So now let's get into that folder again. Now we'll list all files. See, there is another zip folder, and we have another base images folder. So let's get into base images first. We'll list and see there is another image naming as 3c.jpg. So again, I guess we have to run this because this is what exactly means, what exactly the meaning of nested file tracing. We'll have to trace the files one inside another directory, and we'll try continuing this until and unless we get the actual flag of our problem. So let's first again run binwork for this 3c.jpg. That is again it returned a list of entries, and it suggests in the third entry that it is another zip archive data it contains. So again we'll do the same thing again, that is extracting this. It's extracted, and we'll then list all those. See, another extracted folder we get is 3c.jpg. So let's get into for that folder first. We have base images, so we'll continue the same thing. We'll get into the base images. Now we have this 4c.jpg. So again the same thing we'll do, that is running binwork, and by the similar pattern you can understand that this is another archive data. So let's first check the information that is contained within that file. So see, this in the third entry it suggests it is another archive data. So first we'll run the extraction by binwork. It is extracted. Now let's list down, and we have another folder, 4c.jpg.extracted. So let's first get into that folder, and we'll list all the files, and that's it. We have got our flag.txt. So let's use cat and get the flag.txt, and that returned our flag, that is PicoCTF. And as we suggested that all these flags is contained by the curly braces. So this is our required flag for this Matryoshka doll challenge. So we'll first copy this. Now let's get into PicoCTF website, and we'll put the flag here, and we'll submit, and that's correct. So that is our flag for this Matryoshka doll challenge. And now after we have downloaded the shark1 .pcap.ng, and we'll run the Wireshark for this file. And this will actually load all the listed protocols that are being received or sent by this particular file. Now you can see here that there are a list of TCP and HTTP protocol listed here. So basically HTTP and TCP protocols are both protocols are used to connect a computer system to the network. HTTP is hypertext transfer protocol, and TCP is transmission control protocol. TCP contains the information about the file, basically contains the information that the data is whether received or not, and on the other hand HTTP contains specific information about the data, like how to read the data or process the data after it's being received. Now what I will do is I will just save the log of all these protocols that are being sent or received. So I'll save this. So I'll export the object as HTTP. I'll save all these inside the specific directory, inside this directory itself. Now it's saved. Now let's get into terminal again. I'll close this running program, then I'll list all the files. See, there is a lot of files listed here, so I'll basically list all those first. There are a lot of files. It has some particular data and all, but I'll specifically be looking for the files, not other type of data. So I'll filter the results. So basically this will list all the contained information about content information that are being sent or received by the HTTP and TCP protocol. So you can see here that this %2f file only contains ASCII text. Other than that, all this contains data. So we'll first get into this directory. Not a directory, sorry. This %2f is a file, so we'll just run cat for this %2f. And it returns a particular text that is not actually a flag but looks like a ciphered text. So for that we'll copy this and check in the online decipheration. So I'll go to decode FR. I'll go to decode FR cipher identifier. So it will basically identify for me that in which cipher it is basically in the text. And I'll analyze this. So it is most likely to be a row 13 cipher. Now we can check the row 13 cipher in Wikipedia. It is basically a now you can check the row 13. It's basically a letter substitution cipher that replaces a letter with the 13th letter after it. That means A after N, B after O, C after P, and that's like all. So after that I will decrypt the message, row 13 cipher here. I'll decrypt the text and I will decrypt by row 13, and it returns the flag is this. So this is basically our required flag. I'll get into that. Paste the flag. Sorry. I'll submit this, and that's it. That is the required flag for our Wireshark Doodoo problem. Thank you. So that's all from our side, and we have covered all the major categories that comes under capture the flag or CTFs. And now let's look into CTFs conducted by GLUG, that is GNU Linux Users Group. First one is MiniCTF. The GNU Linux Users Group conducts MiniCTF, the one and only of its kind, a capture the flag event exclusively for beginners, to introduce you to the extraordinary and exciting world of cybersecurity and ethical hacking. And the second one and the most important one is FoobarCTF. FoobarCTF, the most awaited and internationally recognized capture the flag event, where you get the chance to showcase your cybersecurity skills before the international community as you decipher various codes and challenges and prove your expertise. So if you want to know more about FoobarCTF, it's listed in the CTF time. You can go and check it out there. Also, if you want to explore more about CTFs, you can get into PicoCTF and PicoGym and practice by yourself. So that's all, and thank you for being with us. This is GNU Linux Users Group. May the source be with you. Thank you so much.